that trigonometry resolving force, it means that, let's say that this is your theta, and we know that this is a, b, and you can either find what is the hypotenuse of this will be a square plus b square. So you use Pythagoras theorem. Or if you want to find the angle, you said tan theta is equal to perpendicular by base. So theta will be tan inverse b over a. And why do you want to know this? Is because so that we can find cos theta and sine theta. If you already know the theta, then you can just use cos theta. But if you want to use the Pythagoras or trigonometry, then you can say cos theta is a over, let's say this is c, a over c, and sine theta will be b over c. Okay, so that is the trigonometry skill that you need to know when analyzing the structure, that truss. And so why do we need this cos theta and sine theta? Is because, let's say that you pick up this joint and you draw all the unknown reaction. This is our reaction. And then again, if you draw your reaction in this way and you get negative, just use that negative. Don't ever change the sign. Okay, just start with that assumed direction and continue with that direction. If it's negative, just put the value negative. If it's positive, just put the positive value for support reaction. So we assume that our reaction will be in this way due to this load P, and then you draw, this is a number of forces A, B, C, D, and you say that this is FAB, and then this is FAD, and then this is FAC, and we have assumed that this is theta. So if I have to resolve this force FAD, because it is an angle, an inclined member, then we can resolve this into F. If we know that this is our global axis, X and Y, so we'll say that this is FDX and this is FADY component. Yeah. Okay, so once we find the FADX and FADY component, uh, how do we know that what is FADX? Like, why do we know that FADX is equal to cos theta, and how do you know that FADY is sine theta? Is always look at this angle. We always take this angle with respect to x. So in this case, if I have to find the theta, because this is a, you see that these are all, you can use a corresponding angle and similar angle, so we know that all this theta will be the same. So in this case, I always tell the students to take theta with respect to x. So in that case, if you have to find, like example, if you have to find this, in this case, if you take this one out, you'll always see that FAD, if you point it toward x, FADX will be always equal to FAD, because this is theta cos theta, and FADY will be FAD sine theta. So in that way, you don't mix up there whether x is cos theta. You don't have to remember, oh, if it x is it kind of sin theta or cos theta. Always make sure that your theta is with respect to the x-axis. And if you do that, then your x will be cos theta, your y will be sine theta. Okay, what if you, like, just to demonstrate why this is important, what if your take this theta is equal in the vertical direction? If you take this theta in vertical direction, and I'm just going to choose only one, which is FAD, and you assume that this is theta, then in this case this will be FADY and this will be FADX. And in doing so, FADX will be FAD sine theta, and this will be FAD cos theta. Then now it's like, wait a minute, we just learned that x is cos theta and y is sine theta. Now you're saying me that x is sine theta and y is cos theta. This is confusing. The reason it's confusing is because is the theta that you are taking the theta with respect to y. That's why this x interchange to sine theta and y interchange to cos theta. So please make sure that you always take with respect to x so that you don't get confused with how you resolve your force component. So in this way, if you always take your your theta with respect to x direction, then you will never get confused whether x is sine theta or cos theta. So you always know that this force will all be, because this is the theta you're taking, so it'll be cos theta and this will be sine theta. So that's the another things that you need to know when you resolve the force. And also you need to know about the trigonometry, because you need to either use the concept of cos theta, sine theta, or you can use Pythagoras theorem to find the length. Okay. And then methods, there are two methods. One is method of join. In method of join, because you are taking at a join, and for a join we have only two equilibrium equations. So method of join has only two equilibrium equation, and because it is two equilibrium equation, then we have only two. You can only uh, uh, take a join. You can only take a join for maximum two unknown forces. So when you see the truss, don't jump into looking at the joint and trying to figure, like trying to solve for any joint. No, you should look at a joint that has only two unknown forces. And what does that mean? That means I can take this joint, I can solve this joint because they have two unknown. So I can start with this joint and I'll find the forces. What if I start with this joint? If I start with this joint, then it has um, four unknown forces, but my available equation is only two. So I should not start with this joint as my first joint to analyze the structure. I will always pick a joint that has only two unknown. So that's why it's good to start with the calculating the reaction, because in reaction, if you know the support reaction, this is known, this is known, this is known, then in that case you can see that I can pick up this joint even though it has three forces, but but this is known, so this is unknown, this is unknown. So it has only two unknown. Because it has two unknown, that means I can use method of join to solve the problem. and and then once this is known, then I can pick up this joint, because this is this is known and this is unknown. So I can jump into a next joint and then find the member forces, because one of them is known, so I have only two unknown. And uh, and that's how we use method of join. uh, Remember that you can only take a join which has no more than two unknown forces. But what's the problem? It's not a problem actually, it's just that you'll have uh, four unknowns but you have only two equations. So you have to do extra work, like you have to spend extra time to look at where how to find all those remaining two unknown. Okay, so it's better to look at the joint that has no more than two known, and then walk from there one by one, and then look for every joint and say, okay, if this is known, this is known, that means I can pick this joint, because this is unknown, this is unknown. So I say, okay, I have two unknown forces, I already know all the other two, so I can use method of joint. So that is method of joint. And what is method of section? Method of section is cutting the section and then you draw all the free body diagram. And this is your x that you cut. Because you are cutting the section and you're drawing all the free body diagram, we can use not only just two equilibrium equation, but also we can use the moment equation, because it has to be equilibrium. So what do you mean by moment? If you're taking moment about a, let's say that this is a, you'll see that this force will create a moment, because this is moment is a force, perpendicular distance is h, so that will create a clockwise moment. This force will create a clockwise moment about a. Okay, so if you cut a section, you can use three equilibrium equation. just like I explained in method of join. When you cut a section, you have to only cut not more than three unknown forces. So this one is good. This one is also good. However, this one is not good because you have unknown, 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 and so you have five unknown, and you have only three equilibrium equation. So you should not cut in this way because you have more unknown than your equilibrium equation. And will it be a problem? No, it's not going to be a problem. It's just going to you have to do extra work to find those two other unknown equation. Okay, so make sure that you cut not more than two. Can I then you can say, what about this? Can I cut this section? Yes, you can cut this section because it has two member and you have three equilibrium, so that's good because you can find the unknown equation, unknown forces. So question is, when do we use method of join? When do we use method of section? If I want to find all the member forces in a truss, then I'll use method of join because that is easy and more faster or efficient. But if I want to find only a join, only member forces at one particular member, then using method of section is easy to do that. It save lots of time. So if I'm interested to find this member, then I can just cut the section for that member and find the unknown forces for that member. So method of section is used when you just want to solve one member for in a truss. But if you want to solve all the member in a truss, method of join is efficient. Okay. So I hope that will help you not to get confused anymore in your truss analysis, either in your FE preparation or in your static class or in your uh, structure analysis class. Thank you.